James emphasized the critical importance of how we scale access. First number one, like, it's the thing about the first number one is the temperature access. Dude, I found this morning that was like drink. Yeah. Was it good?
Yeah, there you go. It's like, but then it's like this, so you can just like
keep it close. Like in a car crash, you sit in the lights. That's great. 20 to 26. See, like an old grandfather clock that lets it. Hello students, you have a warm-up? And at the very least, you'll want to copy this one. The numbers and arrows are important. This one, you know, like, I think you could probably just make a doodle. You can see that my doodle is pretty bad.
What number is this?
This is all number 13. We've spent a day and a half on number what? Don't talk to me anymore. Yeah.
If you copy the diagram,
Dude, chat. If you use what now?
copy the diagram.
I would say so. I mean, you might be able to.
So, at 60 and 30,
At 60 and 30.
Equator.
Equator.
Yeah, the equator. It's just like nuclear. Then N spelled N-U-K-U-L-E-R.
N-U-K-E-Y-E. Anybody know if Katie Rawlings was in my first period class?
Ecuador.
Catherine Rawlings, who was enrolled in period 1. Anybody know if she was here in period 1?
So those spots mentioned are the low pressure zones.
Bodie, what do you think I'm gonna say? Bodie, you're so awesome at using the cell phone instead of taking notes. If there was an award for using your cell phone instead of taking notes, you would win. Number 1, top dog.
Oh yeah,
James has passed on competing today.
What's that say?
And don't forget Baylor. She's a serious contender. That's right. You're very observant. You're catching up. All right. Bravo, Biz. I'm just sort of like getting sick of the phone thing, and like I'm just trying to be consistent. And I pick out the kids that are most visible, but I know there's a whole bunch of kids that are getting away with it. If I wasn't on camera right now, Hugo. If I wasn't on camera right now, bro.
Yeah, those kids with their phones out, that's the worst.
Phones at the front of the classroom. And
And then whoever's phone doesn't get a phone generator.
So, here's a fun fact. Here's a fun
I
fact.
have confidence in my case.
Fun fact. Fun fact. Number one, I did have a phone jammer. I gave it to my homie Tony Jackson, and apparently, like, he still has it. Problem with the phone jammers is they have very limited range, so it would work for you, and maybe this other ring. But check this out. I got a parent who got all litigious on my ass. Because apparently those things are illegal.
They are.
Because God forbid we interrupt your freedom of communication or whatever. And I guess it's like only a federal organization can manage your airtime, and I'm not allowed to do that. And so a parent got all up in my face about it, and I had to stop using it. The other one is, I learned from another fellow teacher of mine that we are covered by the school's insurance if you take your phone and accidentally break it. And like the deductibles or whatever, it comes out so that basically I can just break your phone and say it was an accident. But that's just it. Like, you kind of do, but you have to do like so much hassle that you probably wouldn't. Some weird coincidence like this. Oh, there's some weird circumstance like this. So we were talking with all my teacher friends, like the strategy, like what's the right call? Yeah, because I heard one of the staff broke a kid's phone this year. Miss Nye, I believe.
Yeah. No, she like dropped it.
I believe it was an accident, but everybody was talking about that, and it turns out that like it wasn't an accident. Like, I'm pretty clumsy as it is. Like, might be a credible story to the insurance company that it was, you know, an accident.
Read this police on the internet.
Yeah, I think if teachers started doing that, the insurance company would be pretty suspicious of it.
Yeah, I wonder how many I could get away with. Like, sure, but if I could break just a few phones, I think that would have like a really successful chilling effect.
Probably not any after recording the whole thing.
I know. I would just
Now this is all on the internet. This whole conversation.
Like, it's a weird, like, there's a lot of ways to interpret this conversation. Like, one of them is we're in fundamentally different cultures, you know? Like, I come from a generation where your phone use is rude. You're in a generation where your phone use is, like, part of your life. And so, like, there is, like, this ageism / cultural, like, incompatibility question. Separate from all of that, I feel pathetic engaging you on this. The whole like cat and mouse, like I got it this time. Snapchat, like I get kind of, that's so beneath me. I think what I would stop it. I think what I would like to rely on is straight up like physical threats. Like, we're off campus, Hugo, you watch your back.
Paintball guns. Like paintball guns? Like an air, maybe one of those like just little tiny spring airsoft pistols that you could like
if teachers said
paintball guns.
you could enforce so many things.
I guess I kind of see your point. I personally have like a real, like, I cannot point a weapon at a human. Like, that's just, like, my arm won't do it. It's like RoboCop. I just can't do that.
What if you like throw paper?
Maybe you should get just little less than that.
You know what I kind of feel okay with? Is putting a little salt water in the sprayer like you do for the cat, you know? Like, I'm alright with that. Yeah. The thing is, like, I've done that so much that literally my sprayer doesn't work anymore.
Oh, that's great.
I wore out a sprayer. Oh! Referee!
Stop.
There we go. I won the lottery today. It's like when you go to the mechanic and you go, my car won't start. Dang it, and it starts. Okay.
Well, don't need you anymore.
Is there any class more absurd than Jose's class?
No.
Foresters class, like.
Yeah.
But from a hero lesson in a good way.
But people love him, right? Like,
Yeah.
he's cool, right?
Yeah.
He's a great guy.
You don't like anybody or anything.
He's confident.
He's a good person.
When you leave, I know you're going like, Jose.
No,
I feel like
I like how you guys learned everything. Yeah, you're actually teaching us.
You know, I hear a lot of students, like every year, especially the mad punks, say that about Forrester, and then they get like a good pass rate, and like,
Because we realize that you study our own gives you and give feedback.
Okay, say something.
He says you love them and that we're not using academic science language.
I can tell you a few things about those things. I feel that either students aren't reading it at all, or they're just not taking seriously his assignment.
Yeah.
Because one thing is clear, the stuff that students write on those is accurate but irrelevant. Like if you're telling a story about a car crash and you're like, there was a red Honda Civic and a silver Tacoma. The end. And like, that's not the whole punchline of the car crash story. Those are accurate details that are irrelevant to the meat and potatoes of the story. That's the way that Forrester's article reviews read to me. They're like, there's some scientists from Spain, period. And like, the article's not about the scientists being from Spain. It's about like this amazing, shocking relationship between chipmunks and grass diversity.
Because no one really like puts any effort.
And so the problem that I have is that's what I tell him. Like, I can't tell if they're not reading the stuff or they're just not trying on your assignment.
Because he gives you so much leeway.
You can, yeah.
There's no such thing as late work.
Busy work.
But to answer your question, I skim them. Like honestly, like I haven't read like that volume of writing in my like last 5 years of school life. Like I just, if I have reading time, I'll read more Game of Thrones by R.R. Martin or whatever his name is.
J.R.
Can you believe I'm actually reading that? 80% of it
What?
so far. I have read like 170 hours of that book. The 5-volume like saga. I do not have television.
Anywhere, you don't have
You
television?
should get television just for the show.
Good.
You should.
You're not the first to mention it. Like, I'm kind of hoping for HBO to somehow hook me up in a weird... Like, they're coming out with a HBO-only web stream, but it's going to be $15 a month, so I'm kind of thinking, like, maybe if I get the flu,
For like one
I'll like,
month.
stay home and just, like, Game of Thrones orgy and then just call it off. Yeah. I don't have television.
Online streaming isn't too bad.
They're all cool, dude. I'm broke.
Why are you broke?
I do, yeah, I do have it. Yeah.
You have television.
HBO's not on
coming out of it.
Right. Yep. Yep. We could just talk about this all day. Do you have HBO? Tell me more about your television. All right.
This is Netflix, man. So, where's
All right.
the rank?
Now we get to the nitty gritty. Look. We have like one very simple goal today. You need to explain why every one of those arrows. And when you can explain why every one of those arrows, we're good.
Upload.
We'll do this last. Before that, we'll do this. Before that, I want to review. Did we talk about this yesterday? No. Did we talk about those yesterday?
Nothing on
Holy
this.
crap.
Why did we spend the first half?
Why did we spend the first 20 minutes talking about
Yeah.
HBO?
Oh, it's so worth
it.
That's the worst.
They're rising.
Yeah.
All right, here we go. First of all, heat is proportional to pressure. That's why gases move from high to low. That's also why hot air rises. And you should know that if there's water vapor, as that water vapor rises, it cools and condenses, making rain. All of those rules of atmospheric air movement, I'm sorry, but those have to be like implicitly understood by every student. Like, if you can't look at this and remember those, you're dead. Like, those four are like must know. And I always tell people, think about like a mosh pit. So like, more heat means you're going to get more collision, which is going to like expand the mosh pit. You know, like that mosh pit when people on the edges are like, whoa, whoa, this is too gnarly, and they'll go from those high collision areas to lower collision areas. Think about pressure as collisions, bouncing. Yeah.
What's HML stand for?
High to low pressure. That's why they're circled.
Well, why is there
Convention and maps.
more rain in like low pressure areas?
I can explain that.
If
Now you gotta stop asking your question.
because
Here it
it's so
comes.
cold.
Stop it. I'm gonna throw something at you. So, I'd like everybody to understand why the air moves in what we call a convection cell.
Coriolis effect.
A convection cell is an area of air movement driven by differences in temperature. And you know that temperature is pressure, right? So you could say convection is an area moving because of differences in temperature, or you could say it's an area moving because of differences in pressure. It's the same thing. Convection cell is differences in heat pressure. In Earth's atmosphere, what is the heat source? The Earth, which gets energy from, in the form of, okay, there we go, right? There we go. So, everybody knows that it's not windy when it's dark? Does everybody here realize that there's very, very few winds, like right before sunrise?
Yep.
Sometimes it's really good in the middle of the night.
Yeah, I mean, so there are storm systems that come at night, but if you ever live in a place that's windy, like the wind picks up at around 10 or 11 every day, and the wind kind of shuts down like right after sunset, and usually right before sunset there's like a big gust of wind too. There's a reason for that. All the wind that we feel on the surface is in response to differences in heat pressure. Here's how it works. Turn on the sunlight and the earth gives off heat. As you heat the air, it will rise. Because it's getting further from the heat source, it will cool and eventually condense, making rain and clouds. Everybody go to that? Yes? Do you realize that water vapor, when it cools down to a liquid, is giving away heat somewhere? Because there's an energy loss for the water molecule? Everybody knows that, right? If it's got a lot of energy, that water molecule will be steam. When that water molecule settles down to being a liquid, it's giving off its heat. So technically, there is heat loss at the top of clouds. Water transfers that heat from the ground to the top of the clouds. Yeah.
Is that like why like rain clouds are shaped that way?
Rain clouds. Have any of you ever seen like how thunderheads build like popcorn underneath tinfoil? It's called popping in the clouds. Anybody seen that? Cumulus clouds, thunderstorms, Sierra, Colorado, American Southwest, midday thunder showers. Yeah, Alaska. You have these clouds that are building because there's air slamming into them, which is like forcing the cloud out of the top. As that air accumulates and gives up its energy, it's getting like lazier and colder, so it'll start to fall. It spreads away from the uprising and starts to drop. It'll be very cold and dry at that point because it gave up its water and it gave up its temperature, so you've got cold, dry air falling and hot, moist air rising. And watch this now, because I want to try to see if I can explain how the wind picks up momentum. So stay with me for a minute. Watch. As you build more heat, you get more rising hot, which means you get more air spreading, cooling, and dropping. And you start to build, watch me, high pressure zones where the air is crashing into itself because it's either falling in a big pile or rising in a big cloud, high pressure, slamming into itself. And then you get low pressure zones, which are the place where there is an absence of air. Does that make sense? It's either all fallen away, so there's nothing left, low pressure, or it all got cooked off uphill, so there's low pressure. And so as you get all of that stuff slamming here, all that stuff slamming there, you get high pressures, low pressures, and that kind of starts that crosswind. That's 10 or 11 in the morning. It takes a few hours for this pattern to build, and eventually you build a high pressure and a low pressure, so you get wind across the surface, and you get wind up high. It's called a convection zone. It's driven by sunlight, which heats the land. Hot air rises, cools, falls, rises, cools, falls, rises, cools, falls. And eventually you develop those high pressure and low pressure zones, which get the wheel really kicking. Then you pick up more wind and heat and vapor, and cools and falls, and more heating and vapor, and rains and cools and falls. That's why it always rains in the summertime around like 11, 12, 1, because that's how long it took to build a cloud full of water vapor. Our weather is kind of unique. Everybody's thinking Santa Barbara weather, but we're a fluke. We're on a coastline that faces south, at the place where two of these systems come together. So your experience of weather in Santa Barbara is mostly no weather unless there's a weird Alaska system slapping into Santa Barbara, which is like a fluke in the otherwise nothingness. But this pattern, if you've ever been in any big landmass, Alaska or the Sierra, where I spend my summers in the middle of the Central Valley, you see all of these things go. Yeah, Sarah? Oh, Gabby, whatever. Somebody I want to do it north, yes.
So you said that more heat equals more rise. It's like more rising heat, and then what heat was more wind.
Let me see if I can try that again. More heating of the earth means you've got more air rising, right?
Yeah.
Now what's this part? Because this is the one where like linking the steps for my students is a challenge. So look, if we've got a bunch of air rising, that high pressure gets higher, right? You could technically on a map you would draw more circles around it, right? Because there's more high pressure. And that low gets lower and lower pressure, so you draw more circles around it, right? Likewise, where all that air is falling, you get like a real absence of air, very low pressure, and you get a real abundance of air, like a big old pile of falling, right? So here's what happens. As you add more heat, those pressure differences get bigger. So the more heat you add, the more wind you get because of this one. That's wind. Yeah?
So wind is pressure difference?
Yeah, wind is pressure difference. Every now and then he says something right. Everybody mark this in your diary. This was the day. Yeah.
When the water vapor goes
Yeah.
into the clouds and the heat is released,
Yeah.
that heat, does it just go into the atmosphere?
Yeah, it's called latent atmospheric heat release. Technically, as that water forms, if you take a radar image of the sky profile, there's like a huge burst of heat going up away from the clouds.
Okay.
Yeah.
So if wind is pressure difference, does wind always go towards the area of low pressure?
By definition. There's a bunch of little factors that complicate this. So weather is these pressure systems responding to other details. Weather is how those high and low pressures move around the map. But yeah, wind is always this. That equals wind. That's the definition of wind. Yeah?
So is it kind of like a positive feedback?
Mm-hmm. The more heat you add, the more wind you get. The more wind, you're moving more heat uphill, so you're getting more pressure differential, so you're getting more wind. Basically, you keep adding energy in the form of sunlight, so you keep cranking the convection cell faster and faster and faster and faster and faster and faster until right around sunset, right, when you're turning off the wind someplace, so those pressure differences start to like go to sleep. And that's like the after sunset wind drop. Yeah?
What determines like the initial forming, like, where it's going to form with the initial low and high pressure zone?
Geometry. There's just a lot more land at the equator. It's the fat part of the circle, right? And so you've got more light absorption there, so you've got more rising hot air there. Does that make sense?
Yeah, are we talking about this cycle on like a continental scale or in a small scale?
Both. So on a global scale, equator geometry. On a regional high-low pressure creating weather trends, basically the presence and constitution of land masses. So the snowy part will have less, the rocky forest areas will have more, whatever. Water has less because it reflects. Great questions. Are we done? Can everybody explain the convection cell? You add energy, so that starts to build the pressure difference, it starts to build the wind, which get the convection cell spinning. Yeah? Yeah? Now watch this. Earth has 6. There's 6 of those. They're like donuts around the planet. Like life preservers around the planet. And this is like the one time that I can't give you the right answer. Like seriously, why 6? Because the baby Jesus said so. If you want to know, there's a reason that it's 6. It's a mix of forces. The amount of radiation that we get from the sun, the percentage of water vapor in our atmosphere, the size of our sphere, and the rate of its rotation. So because of the logistics of our solar system, it is 6. In other words, because the baby Jesus said so, it's just 6. And watch me. This is a wheel that's spinning, okay? A gear. Now watch. If I am spinning this way, okay, which for me is clockwise, so I guess for you that's counterclockwise, right? If my right hand is going counterclockwise and the other gear is not spinning yet, what's going to happen when they come into contact? Which way will this hand spin? Opposite, right? Everybody agree with me? Yeah. So if I was going this way, it would drag the other one in opposing direction. Right? They both point up at the middle, and thus they spin away from each other. Right? So, check it out. Our planet has 6 because the baby Jesus said so. It's just 6. It's Earth. That's because it's Earth. The amount of water, the amount of radiation, whatever. We've got those 6. And now, very easy, the biggest driver is the equator because it's got the most sunlight every single day of the year, 12 hours, over the most landmass. So this is the prominent driver, that red arrow. It's all driven by the equator. And then you can spin the rest because you remember friction and the fact that there's 6. Anybody want to ask me something about those 6? There are 6 of these. Yeah?
Do the top 2 ones touch it?
Yeah, there's like a general falling at the poles. You can kind of see it at the top of that. They're like all just folding in at the pole. Yeah.
This is what the arrows going out and going in.
Hold on. That one at the poles, that's why we have a grasshopper effect, by the way. Because everything that reaches the 60s all falls at that one point. It gathers pollution over the top and that all falls at the pole, to answer your question. Now to answer your question, the blue and the red, you mean?
Yeah.
The blue and the red are, where is their hot rising and where is their cold falling? Right, going up means you've got hot air rising, and you know what happens with hot air? This is that one of those rules again. Right? Hot air rising, condensation, rainfall. So now, what?
Wait, hot air rising and cold air.
Falling. Yeah. So now I want to show everybody. Oh, yeah. Go. What? No? Everybody, like, one of my favorite things to show my students all year long. Like, welcome to Earth, everybody. Here's your tour. Please look up. Baby Jesus said so. We got 6. The equator is the most prominent driving force. So hot air rising at the equator makes it all spin like this. You got hot, wet air going up at the red arrows and cold, dry air falling. Now check this out. I'll be right with you, bro. Check this out. Look at the equator. It's all green. Look at the 30s. Desert and desert. There's no 60s except for New Zealand, but look at the North 60s. So wet, dry, wet, dry, wet. I think everybody knows that the North Pole and the South Pole are the driest deserts on the planet, right? There's a lot of water there living as ice, but there's very little precipitation. Everybody know all that? So check it out. That's why. Yeah. The Bob was first. Oh. You gotta admit that's kind of neat, right? Like the band of deserts and the band of rainfall. Like where there's deserts and where there isn't deserts.
So
Yeah.
global warming people say that those like bands of deserts and rainfall are moving, right?
Yeah.
So
Well, I mean, scientists say that. Yeah.
yeah, that's right, scientists.
Yeah. Yeah, because remember I said that those 6, right? Those 6 are set by factors like how much energy coming in and how much water vapor, right? And so the shape of these is shifting as we're holding more energy in the system. Does that make sense? Basically, global warming is trapping heat. That's the definition of the global warming term. And so now that we've got extra energy in the system, then the position of these lines is slightly shifting to adjust. There may be more up or more down or further to the left, further to the right.
Look at the bags like it is like
Right in front of your left hand. I think so. Yeah.
So do you like the Earth moves, let the arrows stay where they are, and then shift
I was saying nothing about the Earth moving. But in case you want to know, any way you look at the planet, the equator is still the part of the donut that gets the most energy with the most landmass. So any way you look at the donut, these are, on average, in the same place. And weather is all the squishiness and flexibility of these. So now when you apply mountains, and you apply icebergs, and you apply valleys, and surface areas with more drag like a forest or less drag like a desert, then we start to make all the little blips and the shifts and the arrows, and that's weather. Extra water in one place, less water in another place, little shifts in the arrows, and that's weather. Like weather forecasters, their job is to understand how these arrows are moving. That's cool, right? Like, by the way, something you all know about deserts. What happens right after sunset in a desert to the temperature? It gets really bloody cold, right? It goes from really hot all day to really, really freezing cold all night. Why? Because you keep adding atmospheric air, like high atmosphere, really cold as that air. That's why it gets so cold. Anybody know why it gets so hot? There's no water vapor to block solar radiation. So your heat gain is very rapid because you've got unfiltered sunlight because there's no water vapor above you. That's why deserts are really hot in the day and really cold at night, because of that blue arrow. And that also explains why the tropics are, by definition, the opposite. The nighttime temperature is almost the same as the daytime temperature, because you're basically in a giant air mass of water. Atmospheric water is very, very, very highly concentrated over the equator. So the equator has almost no temperature variation between day and night, because you're basically underneath a whole bunch of blankets of water at the same temperature. Is this working? Like, you all like this? Is this sort of neat or not? Go over it?
Yep.
Oh. So, now comes the part where everybody wants to judge me because I'm a crappy artist. And I'll just remind you that anything that you have to perform in front of like a huge audience on a daily basis is kind of like nerve-wracking. So being a teacher kind of sucks because I'm like super self-conscious, and I'm also a really sloppy writer, and I also have like no artistic hope whatsoever. See, Daisy's already laughing at me. She doesn't even know where I'm going with this.
Out of all the teachers, you have really good handwriting and really good drawing. Like,
For real?
like, look, I can tell that those are continents. Like, some teachers.
You should see
Whatever you need in your life, I'm here for you.
Gannon.
Yeah.
Oh, Gannon. Oh, yeah, Gannon.
Dan's just good in America, though.
Yeah.
See,
Yeah, that's like
Worcester's like
Texas is
a block.
like.
Yeah, take that.
Daisy, you're my favorite.
Like, I see teachers try to draw circles.
But yeah, Europe is terrible.
Without circles.
Mr. Wagner. Oh, literally. He's very proud of it.
You can.
Wherever I go, I want to take you with me so you keep making me feel better. I am indebted to Daisy.
Wait, why is it
Yeah.
South America?
My suckiness aside, here's the thing. This is supposedly a kind of drawing of the Earth, and give or take 10 degrees, I've kind of tried to line up 60, 30, and 0. Keep in mind, when you look at the Earth, that our land masses are offset to the north. Almost all the land is in the northern hemisphere. Very little land in the southern hemisphere. That's why our planet is shaped like an egg, because gravity pulls on the water. Anyway, you'll notice that these lines are a little bit offset from those because I wanted to look at the land masses. Right? So here's the equator, there's the equator. Now, I put 3 people on the land. I put a person here, I put a person there, and I put a person here. And if you could transfer that, look at the numbers, 30, 60, and 0. If you could transfer those to here, which way does the wind blow for those people? Don't answer. Look. Which way does the wind blow? So this person is standing between 30 and equator. Between 30 and equator, which way does the wind blow? And this person is standing between 30 and 60. Between 30 and 60, which way the wind? And this one is standing between 60 and the north, which way the wind? Okay? If you are this person, does the wind blow from south to north or north to south?
Southward.
From to
South.
see, from north to south. Like that. And if you are in the middle of Portugal, maybe Spain, France-ish. If you're over there,
That's more France.
south to north or north to south?
That's south to north.
Which one?
South to north.
South to north, you're right. South to north. Here it comes. And if you are standing over in Côte d'Ivoire, whatever that is, south to north or north to south?
No.
North to south. Cobra.
Isn't 30 degrees area of low pressure, so shouldn't the wind blow towards the area of low pressure? No, it's being heard by
No.
30 is the area of high pressure at the surface, low pressure of high.
So if the wind is up, it goes the opposite direction. I get the person who's in that.
Yeah, it's a wheel. So if you're at the surface, it's going this way, which means if you're at 30,000 feet, it's the exact opposite. By the way, like, that's an interesting thing. Almost all of the balloons that people see flying away from land float onto land until they hit the jet stream, and then they all float back out to the Pacific Ocean. Hooray for the turtles. We win. All right.
Do that? That'd be cool.
Now comes the part that I hope will be kind of mind-boggling. We all got our north-south, right? I'd like you to imagine what will happen to a lonely Italian explorer slash human rights violator funded by the Spanish government on a very large wooden ship
Large?
setting out from roughly right there.
That is literally the size.
That is what? That is literally what?
If that was the size, if that was to scale. That would
Yeah, that would be the world's biggest ship. So I need one volunteer, please. I need one volunteer. Come on up here, volunteer.
You said the Three Gorges Dam was the biggest thing ever made.
Shut up. You're going to represent me. Okay. So you understand that wind goes from which direction in this block?
Way.
Right. So if you're going to start right there, your wind is going to go south, right? You agree? So you'll just trace that line kind of slowly, like that pace. And I say go. Okay. Okay. So who's going to be the wind? He is the wind beneath my whiteboard marker. And me, I will represent the Earth's rotation. Which way does the Earth rotate? It doesn't rotate, it's flat. You're all a bunch of liberal propagandists. Which way does it rotate?
Jose, there's no direction in space.
Yeah, there is. Relative to north, we can call it. God, Kieran, what's your calling? I'm super nerd. Like, dude, we can do this. Come on. If you look at it from above, it's like a clock or unlike a clock.
But there is no above.
Europe's on top every time. No other part of this conversation. White superiority. Okay. We draw the map, okay? We can put ourselves wherever we want.
We took the picture.
Yeah, damn right. My picture.
Yeah.
Everything's a matter of perspective, and our perspective matters more. Okay, now watch. Now watch. Yeah. Now watch. Imagine how torn I am. I'm from the southern hemisphere, but I'm the descendant of the colonial power that had the most total extermination of any colony. My ancestors more thoroughly exterminated my natives than any nation ever. Argentina. Go Vikings. Here we go. Watch this. If I am in New York on New Year's Eve, the ball drops. What time is it in Santa Barbara?
Hammer time.
9 p.m. or something like that. They've already done midnight. We're not that late yet. Here's another way to think about it. If I am standing in Santa Barbara, which way do I see the sun setting? In the west. Over here in the ocean. But you know the sun ain't going nowhere. We're going somewhere. In order for the sun to move this way, it's not going anywhere. In other words, the Earth must be going... If you're looking at it from above, that would be counterclockwise. Agreed? Yeah? You ready? Put your pen on the X. Get ready, I'll tell you when. Now remember, Luke has one job. You're going to try to intercept that line. You're going straight down. And I have just one job. I'm spinning the earth. Ready, set, go. Find your spot. Find your spot. Bingo! Yeah! Well done. Bravo. High five. Okay, you can go back. Go on. All right. That was a very good job. You see, it's like really, really complicated to get all these little pieces put together because there's so many different forces, but I've got 3.5 minutes to make this all settle. Luke's pen went perfectly from my X down to right there. You can see where his pen came off the paper. Just like he was supposed to do. Straight up north to south wind. But I was messing with him because I was spinning the earth underneath him. So if you're sitting on the surface of the earth, as that wind is going like this, the earth is getting away from you and it moves pretty fast. So that actually makes an arrow that goes that way. Agreed?
So the boat actually traveled on that line?
Yeah, so Christopher Columbus's voyage of discovery is made by cigarette butts and plastic bags every day. All he had to do was survive the floating.
I just realized that only the Earth was moving the entire time.
Exactly. Now, one last principle. Hope, stand up. Hope, stand up. Seriously, it's not that difficult, okay?
I'm standing now.
Damn right you are. Now look, she's going to rotate. She's going to rotate. And I'm going to rotate around all the seated students. Everybody ready?
Yeah.
You will keep your finger pointed at me, so as I move around, you're going to go like that. Ready? Go. Good. You're doing great. No, you're getting ahead of me. There we go. There we go. Okay. Now, I'm gonna start running out of breath pretty soon because I'm old and fat. Who's moving faster? Everybody watch her rotation. Look at Hope for a minute. Look at Hope. And then look at me. Hope, you out of breath? God damn it. Look at me. See this? Who's moving faster? Homegirl or me? Okay. Funny thing is, we're making revolutions in the same direction at roughly the same pace. But the funny thing is, I am covering more land area, so obviously I'm moving way faster. Hold that thought. Hold on. Don't leave it. Don't leave it. Don't leave it. Don't leave it. Nope. I will wait. If you're packing, I won't talk. Now look. The water that has to cover this part of the donut is obviously moving a lot faster than the water at the successively smaller rings, closer to the point of rotation, right? So, this arrow